virtual first based in Germany and the United States. And we are very excited to be part of this American Center for Mobility initiative. We'll be talking to you today about our open source CSMS product, which is purely focused on OCPP 201. And in light of the panel we all heard, I think we all can agree that it's pretty needed. Sana Paris, my colleague, is our director of open source and also the lead engineer on CitrineOS. So she will be sharing a few use cases which hopefully will be useful for you all and can go a little bit into the deeper technical dive of this solution. But before we get into it, I just want to give you a little bit of a background about us. So we have been around for a little over a decade. We worked historically with automotive OEMs on a number of solutions, including charging. And about 7 years ago, we decided to really pivot our business to focus on electrification. Both our founder and our engineering leads felt that this was not only a topic that our people cared about, but the mission of our company is really to leverage technology in support of sustainability. We have a deep experience developing custom CPOs, MSPs, as well as customer-facing applications. So, you know, a few that some of you might have on your phones that you're using to charge your cars today. And our team is an active contributor in the EV Roaming Foundation out of the Netherlands, so advising on the evolution of the OCPI protocol. Currently, I guess, discussing the 3.0 iteration that's going to be coming out. But really, we live in the OCPP 1.6 and OCPP 221. And so why do we decide to devote a portion of our resources and our brain trust to open source? A big portion of that answer was covered by the panel earlier. We were on the ground building a national charging network, the second largest in the US, and we saw not only interoperability issues, but also the process through which companies go when they're standing up a network being somewhat flawed. So from procuring chargers from different manufacturers to trying to adhere to different use cases, and all kind of bundled with what we perceive to be current limitations of the OCPP 1.6 implementation. And so, to be more specific, when we look at things like ISO 15118, plug-and charge, as well as pricing and being able to actually control your network of chargers, we saw that OCPP 201 really was where we needed to move. Timing was on our side because in March 2023, NEVI essentially said, hey, if you want to get into this game, it needs to be OCPP 201. And so October of last year is when we launched CitrineOS. It was accepted into the Linux Foundation Energy shortly thereafter. And we are really looking forward to not only getting the global community to contribute to the tech stack, but also have been fielding a lot of conversations from a number of companies about how can we use Citrine and what does it do for us. Anecdotally, the team that built Citrine and kind of the mission here is that we really do believe some of the silos that were discussed earlier will be remedied through open source. But yet, as the leader of the company, I often get asked, well, how do you monetize that? How are you going to make money? And so, having built this charging software in the past, when we created Citrine, we can say that it confidently reduces that development time by probably 80%. And so, whether it's new players coming into the game that want to stand up charging networks, or OEMs or hardware companies or existing networks that need to migrate to 201, we hope that the open source foundation will really help cut down on those roadblocks. And where we come in would really be once you've leveraged the open source tech stack, you then, as a business, right, which everyone is in this business, you're then able to build on top of it. So it is an API-based modular software, and anything that companies build on top of automatically becomes their own intellectual property. And so a lot of the clients that we're discussing kind of partnerships with and leveraging Citrine, we kind of have two types. We have the company that already has software development, they're already in the charging business, they're looking at our GitHub, they're looking at how we built the tool and looking to leverage it on their own. And then we have, I would say, more cases of companies that are interested to come towards OCPP 201 but lack the internal subject matter expertise and engineering talent to do it. And so they're bringing us in to build on top of Citrine on their behalf to support their various use cases. And so for us, I've already touched on the fact that this is modular. Thana will actually share examples of what we mean when we say modular. It's an extendable software where you can add components to it, and it means that you don't need to take the entire network down as you do that. And we believe that it's really the first of its kind. I should mention we were the first 201 compliant open source solution to be accepted into Linux Foundation Energy, so we feel pretty good about that. And so, high level, Thana will go deeper, but the simplest way to put it is CitrineOS can enable you to provision chargers, to operate them, to actually run charging transactions, and then probably more importantly for a lot of the prospective customers, that you can really monitor the health of those chargers and what's happening with your network. And of course, the residual benefit of it being open source is the fact that this is being constantly tested, and that contributions to this open source then continue to benefit those that might have forked the original code. So, if you use it as a foundation, I think it goes without saying that you will then continue to benefit from its iterations as they happen. And so, yeah, as I mentioned, we've been really humbled by the reaction since we announced this initiative last October, and we've been having discussions with a number of companies from fleet. Hey, I have a fleet, we have depots, we want to make sure that it's DC charging, we know that we want to get, NEVI funding, and so 201 is pretty critical. How do we do that? All the way to, local and state municipalities, and then of course, even home charging. So, the last of that group probably are hardware companies that are looking at it and saying, okay, we want to offer the hardware with the software stack. So Thana will go through 2 use cases, I think we have time for it, that are hopefully relevant for the business that you're in and where you come from. And she will try not to be very technical, although she's very technical. So we will leave, a few minutes at the end for questions, but if I can answer any, I'm also happy to assist. We are in the demo space, and we do have a Citrine demo, and we can also kind of talk you through where the open source solution stops and where some of the custom work starts. So we'll be here today and tomorrow. And without further ado, I'll turn it over to the one who has all the answers. Thank you.
Okay, so before I go into the actual use cases, I'm going to be discussing more about why Citrine, why OCPP 201, and why open source. So to start with, OCPP, we've been talking a lot about interoperability in the panel before this and all day. This is a different interoperability than between an EVSC and an EV. So OCPP stands for Open Charge Point Protocol. It's interoperability between an EVSC and its operator, whoever it is that's controlling the charger. So for example, if you have chargers in the ground at a location that gets abandoned by the original owner, for whatever reason, they no longer want to run that business. If another business is going to come in and make use of those chargers rather than send them to the scrap heap, they need to have a OCPP layer that functions. So OCPP 1.6 has been the dominant protocol, version of the protocol so far, and today it's the most widely used. However, it's come with some flaws. So, for example, if you've ever had the experience of seeing that there's a charger that should be available, and you roll up and it's supposed to be a 150 kilowatt charger, you plug it in and it starts charging at a trickle, and nothing more happens, usually that's the result of a hardware failure that's completely invisible often to the operators. This is because there's not great ways to surface this level of monitoring detail to the operators in OCPP 1.6. In addition, there's sort of fundamental gaps in what the messages allow the operators to do. There's no support for pushing pricing information, UI updates. There's not a lot of security that's intrinsic to the protocol. So what has happened is, in order to support a modern charging network, these messages have had to be extended, and vendors have built back channels that are external to OCPP. And this means that modern charging networks are locked in to particular vendors that support the custom controls that they have made in order to operate those chargers. So 201 is going to solve most of those problems. It was released 4 years ago, but there's been a lack of adoption because it's a major shift from 1.6. And that's one of the major reasons why we started the open source project, CitrineOS. So the second question is why open source? Well, one of the neat parts of CitrineOS is you can go to the GitHub, you can clone the code, and you can have it running on your laptop in about 5 minutes. And then you can start testing OCPP 201 messages with the charger. This means that we've been at the Open Charge Alliance Plug Fests and testing with a lot of different hardware manufacturers. And as those people use Citrine, because it's very easy to generate 201 messages using the software, you can click a button and it will generate an example message for you to send. They will run into issues, they will report those issues, and we will get a form of testing that money can't buy, a diversity and magnitude of testing that otherwise we could not accomplish on our own, or any particular CSMS would have a lot of struggles being able to see. And that's the major benefit of open source. And then in addition to that, as Olga mentioned, it makes it a lot easier to get to market with a 201 implementation. The effort needed when you already have Citrine to start from and you don't need to reinvent the wheel is drastically reduced. So this is our hope that the existence of CitrineOS will provide a robust implementation to test against, to make sure that any given charger is 201 compatible, and that will allow people to have their network use 201 with less upfront investment. So, diving into some of the features in 201 that help with the problems of 1.6. To start with, there's more security. So there's 3 separate public key infrastructures that are maintained within the protocol. One for the secure connection between the charger and its backend, one for plug-in charge. Plug-in charge was not supported in any way by 1.6, so 1.6 implementations have had to do that custom. And then also one for secure over-the-air firmware updates, so that you can replace the firmware on the charger without needing to rely on a vendor back channel for secure updates of that software. In addition, there's improved transaction handling. So we were, in the past panel, there was discussion about KPIs and plugin success. So in 1.6, there's not a configurable way to set what triggers a start transaction message. It happens when electricity starts flowing. And for the purposes of capturing accurate KPIs, this is often insufficient. 201 lets you set where you want the transaction to begin. So it doesn't have to be when electricity starts flowing. You can take it further back. You can have it start when a parking sensor on the EDSC goes off. And that's when you'll get your first beginning transaction message, and then you'll be able to track everything that happens after that until another custom set point, unplug, or maybe when that parking sensor is no longer active. In addition to this, all of the important sequential messages, such as when a charger is uploading diagnostics or when a charger is reporting transaction data, those messages come in sequence. And in OCPP 1.6, there wasn't an easy way to tell if you'd missed one. In 201, these messages are numbered, and there is a robust queuing system for how offline behavior works, which is another thing that 1.6 kind of left up in the air. So you know if you missed a message, and you can configure what sorts of messages get queued when the charger no longer has connection, and this allows you to recover from offline situations much easier. So this is the development roadmap for CitrineOS today. You can see that we announced the project in October. Our first major release, which supports core and advanced security certification profiles, happened in January. So the OCPP protocol is split up into different functional sections. Core and advanced security cover majority of basic use cases. And we used the OCA's testing tool to verify that Citrine passed all the test cases. We have not yet obtained OCA certification, but that will be happening in the near future. We had a second release, a 1.1 release in April that supported 2 more sections of the protocol, advanced device management and advanced UI. These cover a lot of the cases where you get to push data to the charger to show in its user interface, as well as setting monitoring so that you can get automatic triggers if, for example, the max power output of a connector falls below a certain value due to temperature or some problem with the hardware. Coming up in the next release, or 1.2 release, will be ISO 15118 support. We predicted that will be in about 2 weeks. And beyond that, our 1.3 release is going to be covering smart charging, but also we'll be expanding Citrine into the OCPI protocol, which is yet another step north. That's where communication between charge point operators and mobility operators occurs. So if you're looking at your car's dashboard app and you expect to be able to see all the charge points, not just the ones for one company, the way that that data gets to that dashboard app so it can show you both ChargePoint and Electrify America data, that's through OCPI. So we will also be supporting the 2.2.1 version of OCPI, which is currently the most commonly used version. And then looking ahead into July, we will be rounding out the rest of the functional sections of the protocol and have a full OCPP 201 release. So now I'm going to talk about the use cases. So our first use case is an example of using Citrine for public L2 charging. So these are hypotheticals that are rooted in our experience in the industry and the type of interest we've seen in leveraging Citrine since we announced the project. So in this hypothetical, we have a municipality that is installing some L2 chargers at a train station parking lot. They wish to operate them. And they are going to be using CitrineOS to do so, purely leveraging the open source version of the software. So they will be setting up their own server to manage their chargers using CitrineOS. So I'm going to skip ahead a little bit here. So this is a very technical diagram that we're not going to dive into all the details of. But the broad strokes are that up at the top there, you can see the charging station, and it sends data via WebSocket, those OCPP messages to CitrineOS. Within CitrineOS, down there at the bottom, there's a box where there's a bunch of different modules. We split up the different functionalities needed for OCPP 201 into modules so that you don't need to have all of them if you don't want, say, smart charging. And also so that when you're scaling horizontally, it's easier to do so without needing to scale all parts of your software. So transaction handling tends to be the thing that needs the most scaling, and that's thus separated out from a lot of the device management and remote control sections of the software. In addition to the base modules that we have here, we also have an open source module for handling payment. This happens through Stripe, which is a point of sale system that has an API that we can use to do, for example, scan and charge. What that is we query Stripe's API, we get a QR code, which then we can use OCPP 201 messages to send out to the charger. The end result is the user, as they are charging their car, they plug in, they go to the charger, a QR code appears, they can scan it with their mobile app, it takes them to a payment portal. And they can then put in their information to pay for the charge, and then electricity can start flowing. So it's a quick and easy way to set up payments for a charger, and all this is within the open source version. So the outcome here is that the municipality can now operate the L2 chargers in perpetuity, covering the costs of electricity and whatever it takes for maintenance on the server and on the chargers themselves. And they've done all of this without needing to have any paid engagements with a software vendor or a SaaS situation. So our second use case is a hypothetical fleet charging network. And this fleet charging network already has a lot of OCPP 1.6 chargers out in the field. And they have a fleet account portal that has a lot of advanced features in it that they want to maintain, but they're looking to add 201 chargers to their network. So they're going to leverage Citrine to do so. So to begin with, this is what they have. They have 1.6 charging stations. They already have a way to handle the communication from those chargers. And all of the data from those chargers goes to a monolithic piece of software that handles all of the operations of the charger that 1.6 covers. Now, as I mentioned, there's gaps in 1.6. The way this particular fleet use case has handled this is that they have a vendor back channel. This is usually some method of communication separate from the OCPP WebSockets, something like a REST API that the vendor has designed that they use when they sell to the fleet network. So the fleet network has used this vendor back channel to build many of the advanced features in their UI, and now we're looking at buying chargers from different vendors that support OCPP 201. So this is everything that we saw in the first use case from the open source side of things. Here, Citrine is sitting behind the existing WebSocket layer. This is just to showcase how the way that we've designed the software is that it can fit into different sections of the stack so that you don't have to replace things that already work in your charging network. And in addition to the standard modules, we have extended the transaction module so that it can persist data to the old system. This means that the old system's features that relied on that data from the chargers don't have to change. Everything north of that database can remain the same. And then, say there's additional advanced features, such as things that in the vendor back channel gave you access to low-level data about the charger, the temperature of the different connectors, the fan speed. Well, in order to continue feeding that information to the UI and to continue giving control over those aspects of chargers, there's an additional module that just implements the API that the fleet UI is already expecting, and exists within CitrineOS and sends out the OCPP 201 messages needed to handle that functionality. So in the end here, the fleet has been able to use CitrineOS to bootstrap themselves towards a 201 implementation for their backend, and they've broken vendor lock. So they no longer need to rely on chargers, 1.6 chargers that have the exclusive vendor backend that they used to need in order to operate the network with their set of advanced features. Now, any charger that has properly implemented the 201 specification is fair game for them to add to their network and maintain the feature set that they already have. And in addition to all these benefits that I've already mentioned about these use cases, as Olga mentioned, since this is an open source project and we will continue to see contributions into the future, as additional functionality is added to CitrineOS, these implementers will get that functionality free of charge. They can pull in whatever has been added to the open source, and then they can make use of that. So even if they didn't previously have an OCPI layer, now that they're using CitrineOS and OCPI is being released for CitrineOS, they're getting it. So that's another advantage of leveraging Citrine. So here I'm going to pass it back off to Olga to wrap up our presentation.
So that's essentially the crux of it, but just to recap, we feel really passionate that it's 201. We've been getting a lot of questions around what about 1.6? How can you help me? I already have chargers, I've already built a network. And I think that's where our engineering team can come in and really be that guide. They've worked on reverse compatibility using CitrineOS, so there are ways to do it. It just requires some customization. And again, we are very passionate that Citrine is going to open the way for, I think, not just OCPP 201 implementation, but also this whole notion that, you don't have to build it from scratch every time. It's been done, it works, and we hope that it'll help kind of, alleviate some of the roadblocks that I think are, particularly in this country, very much present with EV adoption. So I mentioned previously, but I'll reiterate that we are housed in the expo area, and we do have a demo that we've recorded that supports Tana's position that this can take, within 5 minutes you can have chargers online and see how they're behaving. Additionally, this QR code will take you to our website where we have the same demo housed as well, and you can book a meeting with Jason, who is our head of sales, in the event you want to have a conversation about how we could support you and your electrification agenda. So thank you. I know it's been a long day. Appreciate your participation, and we can answer any